Hi there, welcome back to Matplotlib series of videos. Today I'm going to be talking about scatterplots. I'm going to show you how to make a very simple scatterplot based on x and y values, and then I'll show you how to move into more advanced features of a scatterplot. Scatterplots are a really good tool to show relationship between variables. First, we're going to be looking at a very basic example of scatterplots. Then we're going to be looking at some real-world example that I've got in a CSV file. I've left the link to the code and the data in the description below, so if you want to follow along with me, feel free to go ahead and download the data and the code. If you've been following along with my Matplotlib series, you've seen that I start with very simple examples, then I add more functionality and more visual aesthetics onto each plot. Before I continue, I would really appreciate if you like the videos and subscribe to my channel and help my channel grow. As I always like to keep my notebooks tidy, I'll go ahead and rename this Jupyter notebook. Let's call it Matplotlib _ number 8. This is video number 8. And this one is for scatterplots. From Matplotlib library, import the pyplot module as PLT, which is the nickname that we use. Like always, let's start with making a blank canvas. Give it a fixed size of 7 by 7. You can give any size for your use case. plt.plot. I'll change this later on. This is only to show you how to make a blank canvas, and PLT show. This gives me a white paper for me to start plotting onto. To make a very simple scatter plot, I have written out some random numbers of x and y. So the x variable will represent the x-axis data, and the y will be on the y-axis. These are two ranges of random numbers, no meanings to them, but I'm just trying to show you how to make your first scatter plot. In order to do that, let's run this so that we have x and y in the memory, and let's change plot to scatter. So simply use plt.scatter and x for x-axis and y for the y-axis. Let's look at that. This is the scatter plot of x against y. So as I mentioned before, the most important use case for a scatter plot is to understand if there is a relationship between two variables. By looking at this diagram, I can't really say, well, they are linearly related. To make our plot a bit more meaningful, let's add to it an x label of x because we're plotting x on there, and y label of y. So this will show me that x is down here and y is down there. Let's add a title of PLT, title of x and y, so that x and y can be age versus height. You want to see if there is a relationship between age and someone's height. Let's do more customization on this plot. I feel like I need to add a grid, so that will add a grid onto it. I think it's just a bit too strong. Let's add 0.3. That will make those lines a bit more transparent. One of the most important parameters you can add to a scatter plot is the size of these markers. So they're currently just a bit too small, but I can use the S argument to add a bigger size. Let's bump it up to 100 and see how big they will get. If I go 200, I guess that will be too big. Yeah, I'll probably go 120. You can change the marker itself. We have filled in circles as markers, but you can actually set them to be cross, and you can change them to be a small dot, so that takes it in a smaller size. I'm just going to delete the marker. I want them to be circles. The next thing you can do is to change the edge color. So the edge color parameter changes the line surrounding each circle. If I change the edge color to green, let's see if you can see them. There is an edge color of green around these circles, but because the line width is pretty small, you won't really see that. Let's set the line width to 2, so you can see that gets bigger. What I will do, I'll make it red so you can see it better. And if you change the edge color to 4, that literally kind of covers the whole thing. Let me go back to 2. And also the other thing you can do is actually change the color of the circles themselves. So if I change it to black, the color itself changes to black, and I can change the transparency of the circles themselves. So I set it to 30% transparency, and that becomes a bit less visible. Let's set that to 70, and it is more visible right now. It is obvious to remember that you need the same number of x variables and the same number of y variables. Reduce the number of y by one number, and you will see that that scatter plot is not going to work. So I'm just going to go Control Z and run that again. As data scientists, we always try to make the most out of one plot. So you try to squeeze as much information as you can into one plot, well, not really making it very difficult to understand, but at the same time, to use every dimension of human understanding to make a plot more understandable. For example, say this X here, let's say that represents people's ages, and the Y represents their heights. Imagine your data that the people you're studying are in different countries. So probably you'll say, is there a way for me to show the people in different countries in different colors? I want to understand if these 4 points around here are from the same countries or are they in different countries. This is a very dummy example, but I'm just trying to tell you that we would like another dimension of information in this plot. What I'm going to do, I'm going to bring in a new variable. Let me just make space and call it colors. What I have done, I have produced the same number of elements as there are in X and Y. A person's age is 5, their height is 7. The color I have assigned to them is 7. So instead of saying color equals black, we need to change the parameter color to C. So let's change that to C, which represents color, and say that equals colors. Let's run this. You can see that the markers have varying colors, which is really cool. If these colors have a meaning, then it will be really easy to talk about this new dimension of information on this plot. Let me just go ahead and delete edge color. Now you can see the colors even better. You might not like the default colors that Matplotlib is producing for colors, and you might want to change it to a varying shades of a different color. What you can do there, you can use color maps or C map. That's the variable C map equals something that I'm going to tell you what you can put in. So let's put the quotations here and we will go back to the Matplotlib official website to look at the different color maps. So you can use different shades of gray, different shades of purple, blues, greens, and everything that you can see on this web page. So say if I was interested in different shades of blue, I'll need to use the word blues. Let's go back here and say, okay, I want the C map to be shades of blues. Let's run this. Now you can see that based on the number on the colors variable, I can see different shades of blue. Some of them are lighter blue, some of them are darker blue, which is the product of the color map. Well, let's say if this was how happy this person is. Imagine these numbers show the level of happiness in this person's life. You can say, well, the darker blues are happier people and the lighter blues are less happier people. We need to add a legend. As I have told you, make the most out of your plot. Do not leave people guessing, what are the colors? You need to have that on the plot. I'm going to make a color bar from plt.colorbar, which is a method. I want to say cbar.setLabel and say happiness. Now you can see that this legend adds a lot of info. Let's add just a bit bigger size here because I want this to be square. This is the level of happiness in different shades of blue. You can use different shades of greens. Let's take this to the next level. The other variable that you can change to make your visualization more representative of the data and add another dimension of information to your plot is to change the sizes. Let's go back to the example of happiness, how happy people are in this database. You can actually change the size of the markers based on their size factor. I'm going to go ahead and bring another variable that I have created on my other notebook. Let me just copy that here. And I'm just going to call it sizes, and I'm going to uncomment this. These different sizes will be applied onto the size of these circles. Let me run this. I don't want the size to be the same. I want sizes to vary based on the number. Just imagine that these numbers are showing one person's income. So I'm just going to say S, which represents size, equals sizes. Let's look at this. Now you can see that this is a really cool plot and these circles are in different sizes. For example, this person here does not have a big income, but this person here, great income, their level of happiness is moderately high because that's a darker green. When you present this scatter plot, that's going to be very easy for the person to kind of relate to what you're trying to show. And you don't really need to show multiple plots, because if you did not show the size and the color, you would have to create 3 different plots, whereas right now you have one plot that talks about 3 things at the same time. I guess by now you should be confident about what variables you want to change to make this more representable. For example, this circle here is not really visible, and I wouldn't be comfortable showing this graph to someone where they have to spend a lot of energy to understand where is what. I can easily go ahead and add edge color again, as I had before, and I say, okay, add a black edge color so that people can see them. I'll show you how to read a CSV file through Pandas. If you haven't seen my Pandas tutorial, feel free to go ahead and have a look at that one. It will help you a lot with starting with Pandas. I want to go ahead and read this view data. So this is the data on a specific YouTube channel, how many views each video got, how many likes that video get, and what is the ratio of likes over dislikes. So for example, this video had 8,036,001 views. There were 324,742 likes, and 96.91% of viewers liked that video. Now, let's go ahead and read this CSV. The CSV is in my GitHub repository. The link is in the description. Feel free to go ahead and copy that into your own computer. Because I don't have Pandas imported here, I first need to say import pandas as pd data equals pd.read csv. This is how we read a CSV file, and the name of the CSV file is view data, view_data CSV. Data.head. Let's look at the first 5 rows. It looks very much like what I showed you here in the Excel file. And now let's go ahead and plot the view count against the number of likes. We want to understand, if more people view a video, does that mean that more people will like it? So like before, PLT figure of fig size 7 and 7, PLT scatter of data, the column view underscore count. So this is going to be my X variable, and I'm going to use data likes as the Y variable. Let's go ahead and say PLT show. I'm going to add more details to this graph later, but I just want to show you the scatter plot first. You can see that I've got view count on the x-axis. So this is how many views did the video get, and this is how many likes did the video get. You might wonder, how many points are there here? Well, if you look at the Excel sheet, you will see that there are 200 data for the CSV file. So there are 200 data points on this scatter plot. But I don't quite like the way I have plotted this. What I would like to do, I would like to say, let's make a new variable and call it view count as a separate variable. Just add the view count column from this CSV file as a new variable. That's what I'm doing here. Likes as a new variable equals go to data and take the column likes and put it in a new variable called likes. And also let's make a variable for ratios and say data in a column ratio will be saved there. So this allows me, if I run this, this allows me that now instead of doing this, I can just put view count, and instead of data column likes, I'll just use likes. So that's going to plot the same thing, but it just makes it easier for me to control things. Now let's make this a bit prettier. Add a title to it, and we'll call it trending videos. So that's going to add that, and let's add an X label, call it view count, because I know that I'm plotting view count on the x-axis. PLT Y label will be likes. Okay, this is better. And let's add PLT grid with alpha of 0.3. And what I would like to do now, I'll just add a color of green, add a size of 120, add a bit of transparency, so alpha equals 0.7, add an edge color of black. I'm going to keep adding more information to this plot as we're going on. If you're wondering why 199 points are really skewed here and then there is this one, well, it's a video that had more views and more likes as opposed to rest of the videos. So that's what causing this much skew in the data. But that's easy, don't worry about it. We can use a logarithmic scale or the log scale to kind of get rid of the centering of data points around there in that corner. So what you need to do, you gotta say PLT X scale, set it to log. Let's run this. Okay, now we have a log scale on the x-axis, but it's not really helpful. Now let's use PLT Y scale and the y-axis as well. Let's use log there, and now you can see that the data points are more scattered, and I can actually see a trend. I can make a conclusion that as the number of views goes higher, the number of likes goes higher, which kind of makes sense in a YouTube context. If more people look at a video, they will probably like it more compared to videos that are less viewed. So let's apply more of the learnings we had up here, change the colors and change the sizes based on some variables. A good variable to change colors would be the ratio, but I don't think this would be a good size variable because the numbers are very close to each other. So it means that if I put different sizes on these markers, I won't see a huge difference. But let's try. I'm going to put ratios as the size, and let's see if we can really see size differences. Not really. Well, I can see that there is this little one here compared to this one. What I can do now, I can say, let's change the color based on the ratios. So I'll say C equals ratios. I'm just going to move this one, the next line, and I want to add a CMap. Let's try a different CMap. Let's try summer. And let's run this. Now you can see that not only the size is changing, but also the color is changing a bit. And if I do the greens, you'll see that it's just different shades of the green. I also need to add a color bar. So a C bar equals plt.color bar. I want to add a legend to the side of this graph so that the viewers will understand what I'm plotting here. And cbar.set label will be a ratio of likes versus dislikes. Okay, I'd rather make this a capital D, and I'll increase the width of the graph so that I will have a square one. Okay, you can see that the lighter colors are less satisfaction. For example, this one is more whitish, and the darker colors are higher number of likes on a video. So now, if someone was to look at this graph, they can make a conclusion that if a video is viewed higher, it will be liked more. If you have seen my very first video on Matplotlib, you might remember that there are different styles that we can use to make this plot even more prettier. So let's look at the different styles we have. PLT style dot available. I'm gonna say PLT dot use 538. Well, for 538, I don't really need to use a color bar, so I'm just going to comment these out. That's all for today's Scatterplot video. Thanks for watching. Please like my videos and subscribe to my channel. I'm doing my best to provide a lot of high quality content.